Schematics, the solution to your mathematics.
Hello everyone, this is KK the solution to your mathematics. Today we'll be talking about the regions, the illustration of the regions of the three-set problem. Okay, so as you can see on your screen here, that numbered each region of the three-set problem. You see region 1, which the 1 there is indicating region 1, and 2 there is indicating region 2. 3 there is indicating region 3 and 4, and the same applies to the rest of them as you see on your screen there, and that's our universal set there. So let's move ahead and talk about the various regions. The first region, which is region 1, is what we call the number of elements, the common element that sits between A, or the common number or the common element that's between A, B, and C. So that's the number of elements in A intersection B intersection C. Or we can say all three A, B, and C. That's those that are found in all three sets A, set B, and set C. Now we also have region 2. Now region 2, as you see on your screen here, means number of elements in A intersection C. So that means that those who offer A here, those who offer both A and C. So that is the common thing between A and C, and that's 2. Okay, the common thing that says that both A and C. Okay, and that's 2, which means yes, that's 2. Yes, the next thing we have to consider here is region 3. Now the region 3 now you see here means the number of elements in A intersection B, or you can say the otherwise that it means both A and B. Sorry, we can re-say that it also means both A and B only, both A and B only. Okay, both A and B only. And we consider region 4. Region 4 means number of elements in B intersection C, number of elements in B intersection C, or we can also say both B and C only, both B and C only. Now the next one is region 5, which means region 5 here is talking about A only, which means number of elements in A intersection B complement intersection C complement, which means these number of elements have nothing to do with B and have nothing to do with C. Okay, and it's also called A only. Region 6 is also called B only, or you can also call it number of elements, or mathematically write it in this manner, which is number of elements in B intersection A complement intersection C complement, as you see on your screen here. And the next thing we have here is region 7, which is C only. It's called C only, which is number of elements in C intersection A complement intersection B complement. That's a mathematical form of writing. Okay. Now then, the next one we have to deal with is what we call region 8. So as you see here, region 8 is called none of the three above, none of the three, which is the three are the A, B, C, none of the three sets. Okay, means that this is the complement number of elements that are complement that are not in A, not in B, and not in C, and it's mathematically written as what you see on your screen here. The number of elements in A union B union C all complement. Okay. Now, it's important to note some important things about this, aside from knowing all these regions. We know that, as you see here, the whole of these circle, okay, the sum of all the numbers here, okay, that is comprised in this circle is the number of elements or the number of elements in A. Okay, that's the sum total or the sum of elements in A. Okay, and so equal sum of the elements in A, and this is written as this, is equal to, that is only A, which is, as you can see on your screen there, added to the number of students, or number of elements in A intersection B, and that's A intersection B. Sorry, that's region 3 here, A intersection B. And so we are this to dot, and then we have the number of A element in A intersection C, and that's this. And so we are this dot and this, and then the final one, which is the common value or element between A, B, and C, which is 1. So we are this dot, dot, and dot. And the sum of this should give you number of elements in A. And the same applies to the sum of B. Okay, and the sum of B, considering the B, the sum of every element will, the sum of number of elements in B will give you number of what? Total sum of elements in B. Okay, so the sum of all the elements here should give you what? So that's what we've done here. And so that's the mathematical illustration of this. The same applies to the C also, as you see on your screen here. So we sum everything here, and the sum of everything, every element, number of elements in this whole circle of the C gives us the sum of the elements in C. So, and that is mathematically written as this, as you see on your screen here. I hope you've enjoyed this video, and do follow up for the next video. And please do subscribe. Please subscribe. I beg you to subscribe, like, and share. Thank you. This is KK Mathematics, the solution to your mathematics. Bye for now.